So geometric sequences multiply by the same value every time. Okay, it is important when you write me that definition on the quest that you be sure you say the word same value. Because it's not geometric if you multiply by 2, then you multiply by 3, and then you multiply by 4. It's got to be the same value. Okay, that number we multiply by gets a name. On arithmetic, it was that we were adding, it was the common difference. On geometric, it's the common ratio. And guess what letter we're going to use? R. Yeah. So you're going to see lots of R's in these particular formulas because you're going to worry about your ratio. So in this particular sequence, my ratio is what? 4. Yeah. Okay. Tell me, are these, A, are these geometric, and B, what's the ratio if it is geometric? I go 81, 54, 36, 24, etc., etc. It's certainly not multiplying by a whole number. And how would you figure it out? It's like, on this first one, what's a mathematical way you could have figured out the ratio was 4 using those terms? 12 divided by 3, which would have meant you did the second term divided by the first term. So if you're ever in doubt, if the ratio, particularly if the ratio is a fraction or something, you may find yourself needing to do that. So in this case, you can do second term divided by first term. You can actually do any term in the list, but it's the one farther down to the one that is lesser. So you could do 54 over 81, or you could have done last block. Somebody got it quicker because they said, "Well, I just did 24 over 36." As long as it's the second one farther down the list to the one closer. And either way, 54, and that goes down. So we go to 6 to 9 if you divide them both by 9. But that'll go even farther, 2/3. It actually turns out they're both divisible by 27. Or you could have looked at 24 and 36. Those are both divisible by 12. And you would still get 2/3. So either way you go, as long as you do the second divided by the first, you'll get your ratio. So these, to me, aren't quite as easy to see the pattern unless I give you a nice ratio. And then my other question is, can this be geometric? Can it go back and forth, positive number, negative number, positive number, negative number? So if the ratio was yeah, it has to be -3. So that way, every time you multiply by -3, you're going to change your sign. So it actually is okay on geometrics. If it's alternating positive, negative, it just means your ratio is negative. And that's perfectly fine. You can have that happen. Okay. But we have the same old problem we have on every one of these. What if I say find, even on here, even if I say find the 10th term? Like this one is going down and is going to become pretty nasty fractions. You really want to have to, by hand, figure out the 10th term. No, we don't want to do that. We need a better way. So we need to come up with a formula that will do this for us, because these don't always have nice numbers in them, that's for sure. So I'm kind of going to do it like I did, that's supposed to be 6, though. Like I did last time here. There's a pattern, and it's actually a pretty simple formula. It's not like it's a major big deal. Okay, so how did I get from 2 to 6? I would times by 3. Okay, how do I get from 2 to 18? That would be 2 times 9, wouldn't it? And how would you be getting to 54? Yeah, 2 times 27. Okay, so notice, every time it was 2 times something, why would 2 have been in it? That's first term. So if you'll notice, every time you did it, you times by the first term times something. What do you know about 3, 9, 27? Right idea there. Yeah, because this would be 3 to the first, 9 is 3 to the second, 27 is 3 to the third. So they're all powers of 3. But this is just exactly like last time. Notice, when we found 6, 6 is the second term. What power were you using? You were using the first power. When you're trying to find the third term, you were using the second power. So your power has to always be one less than the term you're trying to find. So if we turn that into a formula, why was 3 the base on this one every time? We're not calling it the difference, we're calling it, that was the ratio. And then what am I going to put as the power? You're thinking the right thing. What do we call that number of term we're on? What letter represents the number of terms? N. So you'd have N minus 1, though. You have to go one less. So you're going to find your calculator your best friend because it'll do those exponents for you and make life a whole lot simpler. So, all right, now we know that formula. Okay, once again, it'll do the same thing as up here. A sub n finds you a certain term. That's its purpose in life, is to find you a certain term. So let me actually have you try to do one here. Suppose I gave you this lovely, whoops, that's supposed to be a 60, no, 160. This is a lovely geometric sequence. And I want you to find me the 8th term. What would you do? We only got one formula, so actually let me write the formula out, then we'll fill it in. All right, so yeah, she's right. We're finding the 8th term, which means n is 8. What's the first term? 150. And then probably the trickiest part, what's the ratio? And so when you look at it and you go, oh, well, this is going down, it's going to be a fraction, then yeah, just do second term divided by first. 60 over, or negative 60 over 150. The zeros are going to cancel. You got to just reduce 6 over 15. And actually, this one you've got a choice. You can do it as negative 2/5, or actually, if you divide that, that's negative 0.4. So you can do it as a decimal. I'm fine if you do decimals if it's exact. But if it's like a fraction like 2/3, which is 0.6666666, if you round it off, like 0.67, it will throw off your answer fairly significantly. So if it's not an exact decimal, you've got to use a fraction. But so your choice. Do you want to use negative 2/5 or do you want to use negative 0.4? It's easier to type in a calculator. So, but either one is okay. Okay, so I have negative 0.4 to the what power? Okay, so what's n? I'm going to write it just so you see it. It's 8 minus 1. You would want to type it in as the 7th power. Okay. What little tiny detail would you have to notice when you were typing this in your calculator? There's something I haven't written that you would actually have to put on your calculator. You will not come out right. Parentheses where? Around the negative. You need it to take that negative to the 7th power. And it will not take the negative to the 7th power unless you put it in parentheses and put the 7th power on the outside. It will mess it up. So if you're taking a negative number to a power, you must have that in a parenthesis, or it's not going to work right. And then, yeah, you're just going to crunch the numbers, and we get, oh, this is our learning about our calculators, too. Okay, calculator's going to spit you out that ugly decimal. A, number one, I'm not real fond of those ugly decimals, and B, your book primarily gives you answers as fractions. Do you remember how to get your calculator to take a decimal and turn it back into a fraction? Control-Enter takes a fraction and makes it a decimal. We want to go in reverse. We've got the decimal. I want it to go back to a fraction. Give you a hint. It's under menu. Anybody? Anybody take a guess what under menu? Then your number. And it is number 2. Yeah, okay. And then approximate what? Yeah, it says approximate to fraction. It's also number 2? Okay. And then they notice last block, once you hit that, you have to hit enter, then whatever it pops onto your screen, you do have to hit enter to make it actually convert it for you. But if you do that on that particular decimal, it'll kick back to a fraction of negative 768 over 3,125. Not exactly the world's nicest fraction either. So you can see how these geometrics, if they're going down by fraction values, you can have ugly numbers. It's much better to have a formula than to have to do it by hand. Alright, so let me show you a case on why would somebody care. This should sound kind of familiar because you've done problems similar to it this year. Okay, we are going to Zeno. I don't know where Zeno is at. Zeno is a city or town, actually. I stole this out of a book, so I assume there probably is a Zeno somewhere. Zeno has some kind of a problem, though, because nobody wants to live in Zeno. Because its population is decreasing by 8% per year. And while 8% doesn't sound like not a lot, if you start looking at it, that's quite a few people to be losing per year. Okay, current population is 2,100. So it's very similar to Seneca in size. Do I want to know? Okay, I want to know what will the population be after 7 more years. If it's currently 2,100 and it's decreasing by 8% a year, what will it be in 7 more years? Okay. Would you even read this and think, oh, that's a geometric sequence? Oh. Why is it a geometric sequence? Okay, so if 2,100 is what the population is now, how do you figure out what it will be in 1 year? So you're saying if I take 2,100 times 8%, I'll know the population a year from now? Because if you take 2,100 times 8%, you're going to get something like 168 people. Is that what the population is next year? 100. Yeah. But I can't do a geometric sequence and subtract. I'm only allowed to multiply. We've done this already this year. If it's decreasing by 8%, what number do you actually need to multiply by to figure out what it's going to be? You're remembering but not quite doing the right thing. If you recall the formula we did for business growth and human population growth, B was your base rate. If you were decreasing at 3%, you had to stack from 100. Weren't you keeping 97%? Yeah. So in this case, if our population is 2,100, next year we're going to have what percentage of our population left? We're going to have 92% of it left. Yeah, we lost 8% of it, but we're keeping 92% of it. So you'd have to multiply by 92% every single time. That rule never changes. Do you all ever, if you're in the store and it's a 40% off item, you're buying 40% off, and you're going, how much is this going to cost me? How do you figure out? That would be the fast way. If it's 40% off, that means you're going to pay 60% of the price, so just calculate 60% of it. Why do 40% and then have to subtract? It's 2 steps of math when you can just do one. So. And that'll tell you what price you're actually going to pay. Yes, her mom does it all the time. That's awesome. Yeah, you use the math skills. All right, so we decided now I need to multiply by 92%. That makes 0.92 be our what? Our first term, our last term, our ratio, our sum. What is that? That's the ratio. So we're using a ratio of 0.92. I want to know what it's going to be in 7 years. So am I asking it to sum up all the years? Or am I needing to find a certain term? Okay, the question is what term am I needing to find? 2100 is the first term. I have to go 7 more years. So I need to find the 8th term, because if 21 is the first one, I got 7 more. That means this one out here is actually going to end up being the 8th term in the list. So we're actually finding the 8th term. So I'm going to rewrite the formula just so it's handy here. If we're finding the 8th term, do we know the first term? 2100, yeah. Do we know the ratio? 92%. And what would my exponent be? Yeah, 8 minus 1 or the 7th power, so yes, I think. And you would once again go to your handy dandy calculator, because who wants to take 0.92 to the 8th power by hand? Not me. And it actually turns out to be 1,171 people. Okay, think about that. This is 7 years later. It went from 2,100 to 1,171. That's a lot of people to lose in 7 years. There is something wrong in this town. That's what they said yesterday. It was a serial killer, but my response is that their cops are horrible too, because they can't catch the. Could have killed all the cops. The last block said, well, it could be the serial killer is a cop. Is that where that came from? Okay. Because I'm thinking like there's some kind of radioactive pollution and everybody's moving away because they're getting sick or something. Okay. The government's testing a biological weapon in this town. All right. So, oops, I need to talk.